All right, hi boys. I've got a video today on prime decomposition. All right. So if you need further information about this, it's on page 140 of your textbook. And I'm actually doing an example that's from the textbook as well on that page. So 3F is the chapter you should be looking for. Okay, so a couple of things to remember with prime decomposition. Lots of things that we've previously learned are included in this new concept. Okay, so firstly, all composite numbers can be expressed as a product, and by that word we mean multiplication, of its prime factors. Okay, so knowledge of what a composite number is, a number with more than two factors. A prime number only has two factors, one in itself, and then of course factors. A factor tree can be used to express this, and that's what I'm going to do today, draw a factor tree. Each branch ends with a prime factor, and you know that you have finished with that branch because the number at the end is a prime. It's a prime number, but also a factor of your first number you begin with. And then at the end, powers can be used to express the final answer. Okay, lots to think about. That will make a lot more sense when I show you an example. Let me just switch my pen. Right. Okay, so I'm going to start with the number 48 today. Okay, now any composite number can be used, and you'll be perhaps provided with one in a question. Okay, so 48 is my beginning number, and that's a composite number. Okay, the next thing I'm going to do is think about what are my factors of 48. Now, to begin with, you only need to choose one pair, okay, of factors. Now, it is absolutely no use to you to pick the 1 and 48, the number in itself, because then you still just have to find more factors. Okay, so don't use those ones, even though they are the factors of the number. So let's think about what are the factors of 48. Okay, so we've got 1 and 48. Now, that's not useful to us today. Okay, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. Now, super important to remember here, it doesn't matter which pair you start with, because you should, if you've done the answer correctly, end up with the same answer for any of these at the end. Okay, so I'm going to start with 4 and 12 just because. I'm going to draw the branches of my tree, the first branches, okay, or a pair. And I'm going to write the factor pair, one under each branch. Okay, now what I need to do is to break down these two numbers, my 4 and my 12, into their factors. Okay, so for the number 4, I have the factors 1 and 4, and then 2 times 2, so I can write 2 twice. Now you can, in between the two numbers, write a multiplication sign if you wish. Okay, that's not totally necessary, but if it helps you remember why you're doing it, then you should do that. Okay, just having a look here at the 2 and the 2, I should notice now that they are prime numbers, so I'm going to circle those. Now if we go back up to our definition, it says each branch ends with a prime factor. They are prime factors there. So I know that I can't make those any smaller or express those with any more factors. Okay, so I'm done with this side. Excellent. Okay, here I've got 12. Now, I could use any pair of factors for 12. Again, it doesn't matter. I should eventually get to the same answer. So I've got 1 and 12 to choose from, 2 and 6, and 3 and 4. Okay, I'm going to choose 3 and 4 just because. All right, so I notice now that this is a prime number, so I'm going to circle that. I'm going to break my 4 down now. These are prime numbers. So I've got 2, 2, 3, 2, and 2. They are all prime numbers, so I can't express those with any more factors. Now, I'm not actually finished with my answer. I've done my factor tree, and that's excellent. I've done really well there. but I haven't actually expressed my final answer. If I go back up, it says powers can be used to express the final answer. So I'm going to write 48 equals, that was my starting number, and I'm going to express all of my prime factors. 2 times 2 times 3 times 2 times 2. Now, I've done this in order that I see them, so 2, 2, 3, 2, 2. Another way you could do that, if it makes it easier for you, is 2 times 2 times 2 times 2. So I'm grouping them together, 1, 2, 3, 4, and the 3 at the end. Okay. We know with our knowledge of powers that there is a more condensed way we can express that answer. So we've got how many 4s here multiplying together, 1, 2, 3, 4. So that's 2 to the power of 4 times our one lonely 3. Okay, that's your final answer. I'm going to show you another example now with the same number 48, but choosing a different pair of factors, and I should still get that answer exactly the same at the last stage. Okay, so I'm going to choose 3 and 16 now. I'll leave that answer at the top so I can double check it. So 48, 3 and 16. Straight away I've got a prime number in 3. Okay, 16, I'm going to break it up into 4 times 4. You could also at this stage do 2 and 8. Okay, that would be totally acceptable as well. So at any stage you can use any pair of factors, but as you get better with this, you'll notice that some lead you to the final answer a little faster. Okay, so 2 and 2, prime, prime, 2 and 2. Okay, so again I've got my answer 48 equals 3 times 2 times 2 times 2 times 2. Now also I didn't mention before, but we write them in ascending order as well in our final answer. So because 2 is the smallest number in that form, I'm going to have 2 to the power of 4. 1, 2, 3, 4 times 3, exactly the same answer as up here. Okay, I'm going to go through one more example now. If you feel like you understand this concept really well, I'd suggest you pause it when I set up the factor tree, try and have a go at this yourself, and then play the video and see if you've got your answer the same as mine. It doesn't matter if in your answer your factor tree looks a little bit different because you've chosen different pairs of factors. What's really important is your expression of your final answer. Okay, so let's say I'm going to choose the number 30. Okay, so again, pause it if you want to have a go at this yourself. I'd suggest that's a really great idea. You can do the working in your grid book. Okay, so thinking on my factors, and at this stage, if you need to write the factors down, definitely do that. So I've got 1 and 30, 2 and 15, 3 and 10, 4, nothing, 5 and 6. Okay, cool. So I'm going to choose 2 and 15. All right, so 2 is a prime number straight away. Factors of 15, 3 and 5. Prime number in 3, prime number in 5. Okay, so I should have 30 equals 2 times 3 times 5. Cool. All right, let's have a look at another example. No powers in my answer there, interestingly. All right, let's choose a more difficult one. Obviously, it's too easy. Okay, let's think about the number 60. All right, so again, I've got 1, 60, 2, 30, 3, 20, 4, 15, 5 and 12, heaps of factors to choose from. That's cool. 6 and 10. Oop. Okay, and perhaps there's more. All right. No, there isn't. Okay, good. So I'm going to choose, let's say, 5 and 12. Cool. Prime number in 5 straight away. Again, you could choose any number of factors here. You could do 2 and 6 or 3 and 4. Let's do 3 and 4. Prime number in 3, 2, 2. Okay, so my final answer, 60 equals 5, oh, whoopsies, ascending order, silly miss. Okay, 2 to the power of, actually, sorry, let's express it properly first. 2 times 2 times 3 times 5. That would be a very highly suggested way to work out your answer there. 2 to the power of 2, because there's 2 of them, times 3 times 5. Okay, good luck.